Good day. Welcome to this lecture on mathematical proof or an introduction to mathematical proof. So I am teacher Melai, and today our objective is to differentiate these terms. So we have axiom, theorem, corollary, and lemma. So to start with, let's start with axiom. So what is an axiom? So it is a true mathematical statement whose truth is accepted without proof. It is also a self-evident, or it presents itself as self-evident on which you can base any arguments or inference. It is also known as universally accepted and general truth. So examples of actions are the following. So 5 is a natural number. 2 plus 5 is equal to 7. 4 times 3 is equal to 12. So even without showing a proof, we already know that this is generally true, or it is a universal true. For every line L and point P not on L, there is a unique line containing P that is parallel to L. So this is another actions on the Euclid's geometry. Okay, so how about the theorem? So a theorem is a statement which has been proved to be true. A true mathematical statement whose truth can be verified. And of course, we are very much familiar with the Pythagorean theorem as an example of a theorem. So here, even if the statement is true, there is still a need to show that it is true. So by, of course, proving it. So for a corollary, on the other hand, so this is a mathematical result that can be deduced from and is thereby a consequence of a theorem. So after proving the theorem, so what other things or what other statements can be said that is also true? So since this statement is derived from the theorem, then it is a corollary. So for the lemma, it is a mathematical result that is useful in establishing the truth of some other result. So it is also termed as the helping result. So let us go back to our example on Pythagorean theorem. So let us show an example of the proof of Pythagorean theorem. So we have here the theorem that if m and n are any two whole numbers, and we know that A is equal to m squared minus n squared, and B is equal to mn, and C is equal to m squared plus n squared, then A squared plus B squared is equal to C squared. So to prove this or to show this, we are going to simply substitute the value of A and B in place of A squared and B squared in such a way that if we are, of course, going to do the operations, we are going to come up with the value of the C squared. So to do this, so let us show the solution. So for A squared plus B squared, so in our given theorem, the value of A is equal to m squared minus n squared. So we simply substitute it in place of A squared. So we have the square of m squared minus n squared plus the square of 2mn, because the value of B is equal to 2mn. So expanding the square of m squared minus n squared, you are going to obtain as a result of m raised to 4 minus, of course, we have 2m squared n squared plus n raised to 4. So of course, if you are still familiar with our rule of the square of a minus b, it is a squared minus 2ab plus c square, or simply you can actually do the long method by multiplying m squared minus n squared multiplied by m squared minus n squared. So we are going to obtain a value of m raised to 4 minus 2m squared n squared plus n raised to 4 plus Of course, if we get the square of 2mn, that is 2 times 2, 4, m square and n square. And then simplify. So what will we do? So combine like terms. So we have the like terms negative 2m square n square and 4m square n square. So negative 2 plus 4 will result to 2m square n square plus n raised to 4. So simplifying it further. So this can also be written as m square plus n square, the square of m square plus the n square. And of course, m square plus n square is the value of c. And then just copy the square outside. Therefore, so this is the major result. Therefore, a square plus b square is equal to c square. So proof completed. So this is the major result. Now, how about for the corollary? So for the corollary, so let's say A, B, and C as defined above are Pythagorean theorem. So the Pythagorean triples. The Pythagorean triples that we are referring here are the value of A, B, C, where A is equal to, so let's go back, where A is equal to m square minus n square. So we are referring here. And then B is equal to 2mn and C is m square plus n square. So A, B, C are the Pythagorean triples. So let's go back to our corollary slide. So which means A, B, and C are Pythagorean theorem. So for its proof, from the theorem A square plus B square is equal to C square. So A, B, and C are the Pythagorean triple. So the result followed on from the previous theorem. So we call A, B, C as the Pythagorean triple. And then for the lemma, so if m is equal to 3 and n is equal to 4, then we get a Pythagorean theorem triple rather of 7, 24, and 25. So the proof is simply substitution from the value of our A, B, and C, m square minus n square for A. This will give you a result of 7. So 4 times 4 minus 3 times 3, or 4 squared minus 3 squared is equal to 7. And then for letter B, 2mn is 2 times 4 times 3. You will get 24. Letter C, m square plus n square is equal to 4 times 4 is 16. 3 times 3 is 9. 16 plus 9 is equal to 25. Therefore, 7, 24, and 25 are called Pythagorean triples. So this is an example of a lemma because this is simply just a small result or a helping result that will show also concept about Pythagorean theorem. So that is an example of our theorem, corollary, and lemma. So thank you for watching.